lower lead times and minimized tooling have been very attractive in production setting in all industries. And these are exactly the advantages offered by additive manufacturing, or more commonly known as 3D printing processes, which are a group of bottom-up, layer-wise manufacturing processes that aims at minimized wastage through minimal machining. My research deals with one such additive manufacturing process called directed energy deposition, wherein a laser beam is used to melt the material powder form of alloy 718 as it is being deposited onto a substrate. Alloy 718 is a nickel-based superalloy which is of primary importance in aerospace and oil and gas industries owing to its excellent mechanical properties and superior chemical stability at extreme temperatures. So, building alloy 718 in tandem with directed energy deposition has gained a lot of traction both from academia as well as from the industries. Process, microstructure, and material properties are interrelated to one another in additive manufacturing processes. My research aims at understanding the relationship between the process and its subsequent effects on microstructure and mechanical properties of alloy 718. The second part of my research aims at analyzing the effects of post-treatments on alloy 718, wherein different heat treatments and their subsequent effects are analyzed.